let's say we have a Kubernetes cluster, right? And we use it to run our different applications. So we have multiple different applications running inside the cluster. So Kubernetes is great making those applications reliable. It can run those applications across the cluster of machines. It can restart them if some of those application pods fails. It can also have built-in features to connect those applications together using built-in service discovery and load balancing. And it also supports stateful applications. So there are many features that make Kubernetes great. But at the end of the day, you still have users. And for those users, you want to deliver those applications. And to do that, you still need to have at least a layer 7 proxy. Well, and in real world, you also need all the other technologies, such as global load balancing, API gateway, web application firewall, CDN, and so on. Another great thing about Kubernetes, so not only features, but also the ecosystem. There are so many tools now built to work with Kubernetes. And also, Kubernetes itself, it runs everywhere. So all major cloud providers support Kubernetes. And you can also run it in your own data center. And as I mentioned, there are tools that work greatly with Kubernetes. And some of the tools, such as Prometheus and Helm, are gaining really wide adoption as well. And it's nice if the proxy that you use to deliver your applications integrate with those tools as well and with the rest of the ecosystem. So how to use NGINX for Kubernetes? This is the subject of this talk. And we will explore the NGINX Ingress controller solution, which integrates NGINX with Kubernetes. But before we explore this solution, let's just see how we can do we really need to have any kind of solution? Can we just use NGINX with Kubernetes in a regular way we use NGINX? So let's have a Kubernetes cluster. Let's assume we deployed our application. Let's call it Circles application with 2 pods. And let's expose this application to our users through NGINX. So we have NGINX deployed on some server or virtual machine. And we configure this NGINX using regular configuration files. And we configure this NGINX to load balance among those Circle pods. And again, Circles is the name of our application. So what are the potential problems of this approach and why it doesn't work? Well, first of all, service discovery. Let's say we want to scale our application to add 1 more pod. So let's do that. Oh, sorry, something get lost in the slides. So let's bring the number of pods to 3. So this means we need to make the NGINX aware of this new pod, right? So how do we do that? Well, with NGINX open source, you will actually need to edit configuration files and do a reload. If it's NGINX Plus can automatically discover backend pods using DNS. So the 3rd pod that was just created will be automatically discovered by NGINX. The next potential problem is configuration management. So let's say we want to deploy a new application. Let's call this application, okay, I think I'm going in the wrong direction again, sorry. Let's call it triangles application. So we deploy 1 pod of this application. So now we need to reconfigure NGINX to be aware of this application so that we can load balance so we can proxy our triangle pod. So how do we do that? So in our case, let's assume we need to add a new location to NGINX. So how do we do that? And so we can always go ahead and edit an NGINX configuration file on NGINX. But this kind of presents a mismatch. So on one hand, we deployed our triangles application using Kubernetes tools. So we use Kubernetes control plane to deploy our new application. But to configure proxy then, we need to manually edit NGINX configuration files. But not manually, but still edit it differently using a different approach rather than through Kubernetes. So that's why it's Kubernetes what? So how can we accomplish this through Kubernetes? And there is an answer. Like Kubernetes comes with the built-in Ingress resource. So this resource gives you a way to configure a layer 7 proxy for your applications on Kubernetes. So here we have a very simple example. So the top of the resource is a standard fields for any Kubernetes resource. So here in the spec, we define that we want to configure a proxy for our shapes.example.com application with this DNS name. And we have two paths. So the request for circles will be load balanced to our circle pods, and request for triangles will be routed to our triangles pod. So this is very simple, but also Ingress Resource supports TLS termination. I didn't include it here, but it also supports TLS termination. But other than that, there's pretty much what it does. It allows you to define these simple routing rules and TLS termination. So, but as we know, NGINX doesn't support this, doesn't understand this configuration or any other load balancer as well. So that's why we need to use, with Ingress Resource, we have the answer. So in order to reconfigure NGINX, we will just need to publish this Ingress Resource that will include the updated configuration for our proxy. But now the problem is how to, NGINX doesn't understand Ingress Resources. So what do we do? And all the other proxies, they also do not understand Ingress Resources. So, and to make the proxies understand the Ingress Resources, there's this concept of Ingress Controller. So the Ingress Controller is a software. It gets all the Ingress Resources running in a cluster, and then according to those Ingress Resources, it configures a corresponding layer 7 proxy. And the Ingress Controller runs in a loop, so that if you make any changes to the Ingress Resources or applications that you load balance, the Ingress Controller will reconfigure the proxy accordingly. So the Ingress Controller typically runs inside the cluster, while the proxy can run either inside or outside of the cluster. So NGINX Ingress Controller. So NGINX Ingress Controller configures NGINX. And in this case, it runs inside the cluster in the same pod as NGINX, and actually in the same container. So with this introduction, let's see a demo of the NGINX Ingress Controller in action. So what we will have? We will have a Kubernetes cluster with 3 circles pods and 1 triangle pod. We will have NGINX Ingress Controller pod deployed inside the cluster that will load, route requests to our circles and triangles. Well, there's one missing piece here, is that to expose the Ingress Controller pod itself to the clients outside of the cluster, you would typically need to use a layer 3 or layer 4 load balancer. So in case of cloud deployments, you can utilize the cloud load balancers. And in case of your own data center, bare metal servers, you can utilize any layer 3 or layer 4 load balancer. You can also use another NGINX in front of the cluster. So in our demo, we will use the NGINX Plus as an Ingress controller, and I will explain the key differences between NGINX and NGINX Plus Ingress controller at the end of the talk. So our demo, we will run it on Google Kubernetes engine. We will deploy the Ingress controller in its own namespace, NGINX Ingress, while the application pods will be deployed in the default namespace. And as I said, we will provision a cloud load balancer to expose the Ingress controller pods to the clients outside of the cluster. And to that, we will provision a service with a type load balancer. Okay, so how do we install the Ingress controller? So the Ingress controller installation is just a matter of deploying the manifest that we provide. And there are a number of manifests that makes up the Ingress controller. And the problem can be, and all these runtime rectangle sized YAML files. So the problem here is that very often, and this will be the case for our demo as well, you need to customize those manifests. And the way to do it will be to edit them, right? However, a more convenient approach to customize the Ingress controller configuration is to use this awesome tool called Helm. In a simple way, Helm allows you to just generate manifests based on some parameters. So for Helm, any application becomes a Helm chart, is represented by the Helm chart. And you can generate Kubernetes installation manifest based on the Helm chart. And if you want to have customized manifest, you will apply parameters to the Helm chart. And this way, you will get customized manifests. And those manifests then you can deploy using kubectl apply -f command. And you can, but the most common way of using Helm, of course, is Helm can also not only generate the manifest, but it can also run inside the cluster, so you can deploy your applications and manage your applications using Helm as well. But for our demo, we will only use the manifest generation feature. Okay, so let's go. Let's hope for the best. Perfect. I hope you can all see it, right? Seems aligned. So I have a cluster with 3 nodes, and as you can see from the output of kubectl get nodes command here. So the first step, as I said, I will generate the manifest, installation manifest for the Ingress controller. So for this, I have this demo.yaml file with parameters for our Helm chart, which I customize. So here, and let me bring the font size up. So here we define that we will use the NGINX Plus Ingress controller from this registry with this tag. And I also specify that I want to, so by default, the manifest will allocate the cloud load balancer if the Ingress controller is deployed on any cloud Kubernetes distribution. And here, by specifying load balancer IP parameter, I tell Kubernetes to try to allocate the load balancer with this public IP that I allocated previously. So now we can run this Helm template. And I'm running this from the Helm chart folder. So the Helm chart file is actually in this folder. So the Helm template command, okay, to point it to this folder. And I also specify the namespace to use. So we'll use the NGINX-Ingress namespace. And I also specify the file to use with the customizations, with customized parameter that I provided. And I will pipe that output into the NGINX Ingress file. Great. So the manifests were generated. Let's just double check that. Yep, so the Ingress controller, so this file contains all these required manifests to install the Ingress controller. So now what we can do, we can just apply -f and deploy those. The first thing I need to do is create the namespace as well. So we'll create the namespace, NGINX Ingress, and then we will apply the install in the Ingress controller using our manifest, again by specifying the NGINX-Ingress namespace. So let's just double check that our Ingress controller is running inside the cluster in a pod. So let's just double check that it is running. NGINX. So the pod is running. So now what we will do with Kubernetes, you can easily connect to your Kubernetes pod from your local machine. So that's what we will do. So we will create a local proxy using kubectl port forward command, specifying the name of the pod, the ports that we want to connect to, and we also specify the namespace NGINX-Ingress. Great, so we established a local connection. So now let's go to the dashboard. So we connected to our pod from our local machine. So this is the NGINX Plus dashboard that some of you are already familiar with. But so this dashboard doesn't show you much stuff yet because we haven't configured NGINX with any configuration yet except the default config. So that's what we're going to do now. So let's do that. So let's go to the next window here. We will deploy our shapes application. So we run kubectl apply-f command, and we have shapes.yaml file that include the service and deployment definitions for our shapes application. Let's just make sure that the pods, the circle pods and triangles pods are running, and they are running. So now we will deploy the Ingress resource. So this is the same Ingress resource that I showed you. The only difference is with this annotation Ingress class equals NGINX. So we use this annotation. If there's any other Ingress controller running inside the cluster as well, it will ignore this Ingress resource if it has the NGINX annotation. While NGINX will handle this Ingress resource because the Ingress class annotation is NGINX. And we need to do that because on Google Container Engine, there's also by default the Ingress controller, another Ingress controller running, which allocates Google Cloud HTTP load balancers. So we want to avoid that. So let's deploy this Ingress resource. It was created. So now let's take a look at our upstream tab of the dashboard. So here we go. We have our 3 pods of circles in this group. Oh, let me just use it. And we have our triangles pods here. Well, the application is very simple. So if you go to shapes.example.com, and yeah, this DNS name is doesn't exist, so it mapped into etc.host files. So you can access. Well, you can try to access it. So I can write kubectl get ingress command, and you will see that our Ingress resource has this public IP address. So this is the public IP address of the Google Cloud Load Balancer, which we allocated to expose the Ingress controller. So you can try to hit it if you want to. So now let me show you what's actually happening inside the Ingress controller container. So what config do we have there? So we will run this command. Let's go back to our to this window. So we run kubectl exec-it Ingress controller pod name, specify the namespace, and we will run the bash inside our container. Great. So now let's go to the etc.nginx folder. Okay, here we are. This is some configuration files, some default configuration files, and we also have here the main nginx.conf file, which we actually generate. And I'll explain you how this config file is generated in a moment, but here it is. But the important thing here is that it actually includes configs from other folder. So it includes here. So, and this folder stores. If we go to that folder, we will see that currently there is one config file that corresponds to the Ingress resource that we have deployed, and we can take a look at it. So this is that Ingress configuration that correspond to that Ingress resource. So it has 2 upstreams, which we saw, and it has the virtual server. Oops. It has a virtual server for our shapes.example.com domain, and it has 2 locations, so the circles location and triangles location. So it looks like machine-generated config, so because the Ingress controller generated it. So now we can exit our container, and this concludes the first demo part. So let's go back to our slides. Oh, here we go. So we deployed our demo, and so we were able to deliver this shape circles and triangles to our users. Now, I showed you let me just double check how much time do we have. Thank you. So let's just understand how the config file is generated, because one of the important parts when using the Ingress controller is how to generate the right config for our Ingress resources. Because as we saw, the Ingress resource is very limited, so it only allows you to define simple routing rules and TLS termination. But of course, NGINX has many more features available, and so very often you would like to use them. So how do we do that? To understand that, let's understand how the config files are generated. So first we have the main nginx.conf file, and it is actually generated from the template. So Ingress controller is written in Go, and it uses Go templates to generate the config files. And so we have as a user, you have control how the main nginx.conf is generated. And this control comes in the form of the ConfigMap resource. And let me show you the example of the ConfigMap resource. The ConfigMap resource is a general purpose resource on Kubernetes to store configuration. It consists of key value string pairs. Our NGINX Ingress controller understands certain keys. So for example, here with this ConfigMap, we define the number of worker processes, and we also define the log format. Of course, we also provide some additional, Ingress controller understands additional ConfigMap keys, such as SSL ciphers, connection timeouts, and so on. So the first thing to do is to customize the nginx.conf file, which you would typically want to do, at least to change the log format, for example, you will use the ConfigMap resource. And now, as I showed you, the nginx.conf file actually includes other files from the conf folder, and those files correspond to the Ingress resources that we deploy in the cluster. So how are those files generated? So we have the Ingress resources, and similarly we have this template file, the Go template file, which we use to generate the configuration for Ingress resources based on the definition from the Ingress resources. However, the same config map that we use to customize the nginx.conf file, we can also use it to customize the configuration files for Ingress resources. And let me show you another example of such a ConfigMap resource. So we extended the previous one. So now we use the lb method key, and we specify the list time algorithm. So this will telling Ingress controller to configure upstreams across all the Ingress resources that you have with the list time load balancing method. Okay. There's also another way to customize the configuration for the Ingress resources, and this is to use annotations. And annotations are the simple string value keepers that you can attach to any Kubernetes resource, including Ingress resources. So here we go. Here this is our that shapes that example that come from a demo, Ingress from a demo. So we add another annotation here, nginx.org lb method. And using this annotation, we tell nginx to generate, we tell nginx to use the random load balancing method, random of two choices, for all the upstreams for this particular Ingress resource. And so some annotations, we have ConfigMap keys and annotations for the same features. So in this case, annotations override ConfigMap values. There's a special kind of, so this is now the advanced part. There are a special kind of ConfigMap keys and annotations called snippets. With snippets, you can insert the raw nginx configuration into different context of generated nginx configuration. The main context, the HTTP context of the main configuration files, the server context, and the location context of the Ingress configuration files. And so we have snippets available through the config map, and we also have snippets available as annotations. So we have two annotations the server snippets annotation and the location snippets annotation, through which you can customize the configuration of the Ingress files. And yeah, again, annotations override ConfigMap keys. So here, an example of using snippets, the server snippets annotation, to insert a raw NGINX configuration into the configuration generated config file for this particular Ingress resources. So in this case, we will insert a location, and this location will redirect all the requests to the /URI to the circles path with a temporal redirect. So, and the last thing here for customization is, so those templates that I mentioned, they are Go templates, but you can easily customize as well. So if you want a full control over how the generated config looks like, so you can actually customize those template files. And what's more, you can also include those templates file as raw strings here in the config maps, in which it makes it easier for you to manage and update. And I will not show you an example because it will be too verbose, but this feature is available. So this is the summary of all the advanced configuration methods. So we have the ConfigMap keys and annotations, and they're very easy, straightforward to use. We have the snippets, and snippets are more low level because you're working with raw NGINX config. So that's why the medium complexity. And we also have the custom templates method. So if you want a high level of control over how any config is generated, you can customize the template. But I consider it as a hard exercise because it takes more time. And it's more error prone. So I don't have time to and we already we were cut from the beginning, unfortunately. But there's also another feature available, and if you would like to talk with me, we can talk today or tomorrow. So you can also write by customizing the templates, you can add your annotations. So for example, if you want to add annotation to support rate limiting, you can easily do that by customizing the template and only that. And yeah, so this is our set of annotations to support rate limiting. And this way you can also support other NGINX features in your own custom way. And the complexity of these custom annotations, again, is hard because you need to customize the template. However, if in your case, you have different people who manages, people who use the Ingress controllers and who actually, runs and manages them. If those people are different, so it will only be hard for the admin to write those custom annotations, but will be easy for the users to use them. So I'm going to wrap up. How much time do I have? It's a negative value. Q&A. Yeah. So the next talk here, my colleague Brian will talk about Prometheus and how to monitor Ingress controller using Prometheus. We also support TCP UDP load balancing through the snippet. So this is so Ingress Resource does not support TCP or UDP load balancing, only for HTTP. But you can use TCP UDP load balancing with NGINX Ingress controller by inserting streams, inserting a raw NGINX configuration using stream snippets. And in this example, we load balance the core DNS server. So in this case, we load balance the TCP DNS over TCP. But you can also load balance DNS over UDP on the same socket. So you can extend this example. And again, if you want to speak about me, or we can do it afterwards. So I hope this was a good introduction into how effectively use NGINX to load balance and deliver applications on Kubernetes. So the benefits of NGINX Plus, using NGINX Plus with Ingress control, is those advanced features that are available, and as well as the dashboard. But also the very important benefits is using dynamic reconfiguration. So Kubernetes is a very dynamic environment. That's why we often scale your applications up or down. So that's why support for the dynamic reconfiguration of upstream servers becomes important when you have large deployments and frequent scaling events. Well, there's also NGINX Ingress controller built by Kubernetes community, so check this out, that project as well. High level, they're very similar, but they're also different in the implementation and how the config is generated and what config is generated. So with that, I'd like to finish my presentation. Thank you so much. And I think we have time for a few questions, right? Yeah, I get a confirmation. So please. Yes, please.
Are the snippets available on mergeable ingresses?
On mergeable? Yes. So snippets. So good question. So there's also mergeable ingresses, which is another feature that we have that I haven't explored. But this feature allows you to split your path definitions across multiple Ingress resources, and it becomes easier to manage. And yes, location snippets are available for mergeable Ingress resources. Yes, please.
So which one do you think, if annotations contradict each other?
Oh, so in this case, if they're mergeable, so they cannot contradict each other because they isolated to the location block. So they will be independent. So that's why they cannot, collide.
Why specify volumes for cache in the Ingress configuration?
So with Ingress controller, we don't specify we don't support caching, but you can extend the Ingress controller, to support it. But that would be, you can customize, you can insert, snippets, for example, or use custom annotation, and then you will have to change your, deployment manifest to have the volumes, if you would like, to support caching. Yeah. So, well, thank you for your questions. Yeah, sorry for this mix up.